holes, small pops and shifts around the surface and chromosphere region. Without sunspots. The only item of note is the solar wind from the coronal holes. Minor one clipped us slightly the last day. We had seen the impact beginning in yesterday's show, and you can see it never really amounted to much. Little weather note to springboard into the science today. Record snow Easter weekend in Fairbanks. Not sure what it takes to have record snow in Alaska, but yeah. Up next, we're taking a little detour to cosmology in the realm of the circumgalactic medium. In line with the ongoing pattern of seeing larger and more expansive plasma halos around galaxies. Here, they find a 3 to 5x error in CGM density estimations based on the most common methods, and this is one of the first times I've seen such a paper take the next step and actually say that our modern ability to see the CGM lacks the quality to make conclusive judgments about it, and the observers chime in all together, no kidding. Up next, as a response to the numerous papers over the last 2 years claiming modern climate model failure in paleoclimate scenarios, they tried to make an ensemble. I'm not sure which is more fitting, a spelling error in the title of a paper published in AGU journals or the fact that the only improvement they were able to make was in the low data resolution highest error regions, due to the now greater coverage. Up next, we're heading to Greenland where a new study has detailed some of the controlling factors on glacial loss. Rather than the sunlight or precipitation or even surface temperature, the water intrusion to the base of the glacier is controlling. The water not only helps to melt, but it lubricates and pushes the glaciers along the way. Now folks, our top story today deserves as much explanation as any other, especially with where the study authors left off. Let's start with the good. Brand new study demonstrates another way to statistically tie the solar cycle to El Niño and La Niña. Their statistics are as robust as any other, but they do make a few mistakes. First, they believe they were the first to use the 22-year solar magnetic hail cycle. Heck, that's all over the literature on solar forcing. You can even find a number of those studies declaring that 22-year climate forcing pattern in our textbook. Shots from that here. Now, while the main conclusion of the paper is a solid one, it should go further. They say they don't yet have the mechanism, but that it may involve cosmic rays. Well, they're partly correct there, but they don't need to be guessing, because the mechanisms of solar forcing are already well described. They involve the major electrodynamic and wind patterns of the planet, the large-scale cells. The tropical Hadley, mid-latitude Ferrel, and high-latitude polar cells control where heat flows and how quickly, along with the positions of the pressure cells and the jet streams and polar vortex. These are affected when the sun modulates cosmic rays, which modulate clouds and affect both surface heating and atmospheric electricity. So if I can quickly summarize the literature review in our book and videos on this topic, it is well established that the Hadley cells expand during sunspot maximum. This pushes the jets towards the poles and allows tropical heat to expand its coverage. At the same time, the higher solar energy blocks out more cosmic rays, which means less clouds reflecting sunlight and more sunlight hitting the surface. All of those things, tied to high solar activity, lead to higher temperatures overall, and especially in the Pacific ENSO zone, while the opposite in sunspot minimum, all would lead to cooler Earth and a cooler Pacific, the La Niña events tied to the study. This is one of the key avenues of solar cycle forcing. It is fully described in our textbook at otf.cells.com and in the climate playlist listed right below the video in the description box. We greatly appreciate your support. We've got wind maps and shots of our star to close. Subscribe and we'll do this all again tomorrow, right here.